Hello, my lovely students. Hopefully you had a good spring break. So the sections we have now are 4.4 and 4.5. 4.4 is pointless. I have never seen these formulas outside of this section, There is maybe a chance that you might use them in a weird problem in Cal 2. Maybe just the product to sum. But that's it. And even then, if you need to use it then, you go look up the formula. It really comes down to how often do you actually multiply trig functions with two different angles? You don't. But we're going to practice this as how do you use a weird formula you're not really familiar with? So pattern matching. That's what we're going to do, because you will do that at the end of Cal 1, beginning of Cal 2. There are long lists of ways you can do integrals. And it basically is like the shortcut cheat code, if you will, of you have this kind of integral, poof, here's what it equals. So you don't have to do all the in-between tedious work and figure it out. You're just like, oh, I use the formula, it's this, I fill these numbers in, answer. So we're going to treat it like that. So here's our first formula. Cosine alpha times cosine beta can also be written as 1/2, the brackets are all the way around, cosine of alpha minus beta plus cosine of alpha plus beta. So write the following product for cosines as a sum. All right. So I can put this at the top, and then I think I will put it over here. All right. So let me first point out, there is a 2 there. It is very easy to lose that 2 in the midst of the whole formula. All right, so this is our alpha, this is our beta, and we could do it the other way around. It really doesn't matter. That is like the worst alpha. All right. So my cosine alpha, cosine beta. Now notice I had that 2. So if I put a 2 on this side of an equation, I would also have to multiply by 2 on this side of the equation. And 2 times 1/2 will cancel out. So they wrote the 2 there, so we don't have to worry about the 1/2. It's like kind of nice, but if you miss the 2, then it pisses you off because Weber is like, no, your answer's wrong. And you're like, no, it's not. All right. So 2 cosine alpha cosine beta equals 2 times 1/2 cosine of, oh, sorry, that is an x. Cosine of 7x over 2 minus 3x over 2 plus cosine of 7x over 2 plus 3x over 2. And terribly sorry, there should be brackets. Right. So now the inside stuff here, we can map that together, and they already have common denominators. It's very common for them to do in problems like this. So 7x's minus 3x's is 4x's. So this is the cosine of 4x's over 2 plus the cosine of 7 plus 3x now is 10x. So 10x over 2. And this can be written then as the cosine of 2x plus the cosine of 5x. And that's it. This does not magically become the cosine of 7x. It doesn't become a cosine squared. This is cosine of one angle plus cosine of a completely different angle. We cannot interact these, we cannot combine them. So trig functions, unless they are perfectly identical, they're not going to be like terms. Now, technically, we should have parentheses like that. But without the parentheses, that is what the assumption is when you write cosine of 2x, that the 2 and the x are inside the cosine. And then plus another trig function, that is assumed to be not inside, because we don't put trig functions inside each other. It's nasty. All right. And now we do it again. So alpha, beta, and we don't have the 2 this time, so I'll just start with that 1/2. Now, I could swap it around so 4 theta was alpha and 2 theta was beta, but I'm just going to do it as it presents it. So 2 theta minus 4 theta plus cosine of 2 theta plus 4 theta. All right. Cosine of negative 2 theta plus cosine of 6 theta, still with the 1/2. I can technically go one step further, and I'm going to do it here, but I don't think WebWork will actually force you to do this because the answers are equivalent, and it just, the way it checks things is not, it's not a literal check. It's checking to see that the thing you typed in produces the same answers as what it thinks the answer is. So cosine of a negative angle, remember cosine is even because it starts at 1 and then it mirror images even functions. The positive side is equal to the negative side. So that means cosine of a negative angle is always equal to cosine of the positive angle. So I could also write this still with the 1/2, but I could make this positive 2 theta. And then it would still be 6 theta. And you remember before I said I could swap the alpha and the beta? This is why. If I swapped it, then it would have been 4 theta minus 2 theta and 4 theta plus 2 theta, and we would have had this answer. So they're all equivalent. Whatever WebWork takes is fine. Like I said, the odds of you using any of these formulas is so slim to none, it's ridiculous. All right, writing the product as a sum containing only sine and cosine. So now we need a new formula. Oh, look, it's right here. Almost like I put the notes together like this. I need like little pop-up memes when I make a face like that, I think. But I'm not a video person. All right. So equals, keep the 1/2, sine alpha minus beta plus sine of alpha. Yep. All right, so alpha is 4 theta. And then beta is 2 theta. Right? So just to be very clear about, if you're not comfortable like plugging in as you write it out, and you can even write it in with the alpha and beta, then say, okay, alpha is my first angle, 4 theta, erase the alphas, write 4 thetas. Then beta is 2 theta, erase the betas, write in the 2 thetas, or whatever it's wanting you to do. So now we have 1/2 sine of 2 theta plus sine of 6 theta. Trig functions, there's no way for that 1/2 to go inside and simplify. Type it like that. You could also type it sine 2 theta plus sine 6 theta all over 2. So if you just wanted to type one giant fraction, you could, but meh. But it doesn't simplify anymore. This is literally plug in the numbers, type what you got. Just do the little add or subtract inside. That's it. All right, now, well, this is what we were just doing, sine and cosine. So another sine and cosine, but they made alpha and beta look ugly. So let's be a little more careful with this one. So I have my 1/2, I have my sine. So alpha is this ridiculous x plus y. So I am using the parentheses around the x plus y because there's more than just multiplication in there, so I want to be extra careful about my substitution. And then cosine had the x minus y. And you see right here, that minus sign has to be distributed through the following parentheses there. So it will matter. It is going to make a difference. All right, so let's go ahead and clean up some of this mess. And give ourselves a little more space. So still have the 1/2, still have the sine. So this will be x plus y minus x and plus y. So we end up with 2 y's. All right. Plus, then over here, we have the sine of x plus y plus x minus y. So now the y's cancel and we have 2 x's. That's it. I mean, I could technically use like the sine double angle formula here, but that doesn't make it prettier. And this is a sum. That's what they told us to do. Use the product to sum. It's now a sum instead of a product. Done. But notice here, sine had x and y inside, and now sine, the x's and the y's are separate. I could minus one to the other side of an equation, or look at the two things separate and then add results back. Like there are times when this is a very powerful tool. But most of the time, you will not need it. And then look, more formulas. Now it's product to sum. So I'm going to cut it here and then do another video.